The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to the session today on the Plant3D User Community Meetup for July. My name is Jason Drew, and Joel Harris is joining us today as co-presenter.
Hello, everybody.
So we'll go ahead and get started here as people are joining. So just before we start, some information on the GoToWebinar here. We'll go ahead and keep the lines muted to reduce background noise. But if you have a question, feel free to raise your hand or type in questions to the chat box if you're comfortable with that. The session is recorded, so if you have any issues with that, please disconnect now. We will make this recording available after the end of the session today, probably posted tomorrow, and also go out on the YouTube playlist that we're linking in here to the PowerPoint slide deck. So we'll also post the slide deck along with the video so that you can get a copy of that afterwards too. So just real brief intro on myself. My name is Jason Drew. I'm a designated support specialist here with Autodesk and mainly providing technical support to our enterprise customers, enterprise support customers, and the Autodesk communities. On the following products here, I'm mainly specialized in Plant3D, P&ID, and Navisworks. And previous to joining Autodesk, I spent about 10 years in IT support, doing general deployments, things like that, network troubleshooting. And I eventually got into P&ID design, an oil and gas company in Tulsa for about 3 years with Smart Plant P&ID. And then eventually around the 2008 downturn, got a hold of the plant software from Autodesk through the Displaced Worker program and started learning that, and then joined Autodesk as a support specialist. So I've been with Autodesk for about 8 years now. And I will go ahead and hand it over to Joel to do his intro.
Okay, thanks, Jason. So I basically been with Autodesk for, well, it says 5 years there, but it's actually 6 years now. Before that, I was in industry as a piping designer for 23 years with an engineering company. And before that, I was an AutoCAD partner, developer, reseller. And so basically, I've been in the plant business for 29 years now. So hopefully I'll be monitoring the questions, the Q&As while Jason's talking today. And so I'll try to answer your questions there. So go ahead, Jason. Thank you.
All right. Thanks, Joel. So for the agenda today, we'll do a quick overview. We'll go into some news about Plant3D, just some general updates. And this month's theme is a deeper dive into interoperability between Revit and Plant3D. So last month we were talking about when to use Revit versus Plant3D, and this month we're going into how to share models between those two applications. We'll also go into some follow-up from questions from last month, and then at the end we'll have some open discussion, Q&A, so you can bring up any kind of topics you want. We'll go through those live. So kind of overview for the session, we'll talk about Revit PID Modeler, which is something built into Revit that we'll want to show. We'll talk about using CAD links to bring Revit models into Plant3D, and then how to bring Revit models over into Plant3D models into Revit, and then vice versa, Revit to Plant. We'll also talk about Bin360 model coordination and coordination spaces. So that's something that's fairly new that's come out, and we'll talk about how you can share models up there for some clash detection and coordination. And just want to note that these monthly sessions are intended to be casual engagements. So like I said, we go through the news and information, provide some workflows and things like that each month. And then towards the end, it's the intent is that the discussion is driven by the audience. So anything that you want to bring up, we'll do that in the Q&A portion as well. So real quick here, a safe harbor statement. Now, I won't read through all this. It's basically saying that we may be talking about future statements on planned development efforts, products and services. So I ask that you just don't use those for a business decision until the products are fully released. We maybe talk about something that's coming down the road, and things change, schedules change. So make sure that you just use discretion there if we talk about something that's new. So as far as Plant3D news, the main topic we have is around the cloud collaboration for Plant and the server location. So starting here just recently, we have an option to set up a new Bin360 hub, so to speak, or project locations over in the European data center where all that's hosted. So if you have a group that's working in that region, you want to get the data a little closer to them, you can actually do that now when you set up a new hub for that. Now it does require, like I said, a new agreement. You can only do that with a new, like setting up a new project environment, and there's really no way to take like existing data from the US servers and just port that right over to the EU servers. You'd have to back that up and then re-upload it into the other data center location. So there's a link to an FAQ down here. It's going to give you all the information about that and give you some of the details. Most of the modules are supported in the new data center. I think there's only one thing, like the construction IQ here. It's part of Insight that may not be there yet, but most everything else is there and available, ready to go on those data centers over there. So going into our first topic here, PID Modeler for Revit. So you may have seen this before or heard about it. So PID Modeler has been out for a little while, since Revit 2018, and really worked before with the old with the Teams environment with the cloud. Now it works on Bin360 Design or Docs. So this is a feature that allows you to take the information from your PIDs that are created in Plant and use that in Revit for modeling. So basically what you're doing is enabling collaboration between project team members. And so really taking that data that you put into the PIDs and utilizing that over on the Revit side of things when you start to model the PIDs in Revit. Now this does work or require that you have your project for Plant stored up in the cloud, like I said, Teams or Docs. And with 2021, it would be on the Docs platform there and Bin360 Design. So really, there's some features there that bring the data over, but also allow you to do some consistency checks between the models to make sure that the tag numbers match up for equipment and lines. Just making sure things are where they need to be as you're modeling from those PIDs. So we do have a quick overview video that we wanted to show on this to kind of so you can see how it works. So it runs for about 6 minutes here. I'm going to bring this up and stream it. So we're going to do the first one here. This is modeling pipelines in PID Modeler. So I'll go ahead and kick that off.
First, select the pump. In the Properties palette, notice that currently the pump has no PID tag set, so it will use the shared parameter that the PID tag property has been mapped to. Let's map the PID tag property to P-1005. Right-click the line number element and click Map to Existing. Notice the tag is automatically populated with the line number. If there's a change to the PID, the next time you upload the plant model to the cloud, you'll see an indication in Revit. For example, if the value of the tag in the PID changes from P-1005 and the model is uploaded to the cloud, Revit makes you aware of the change. To demonstrate this, in the Properties palette, let's change the PID tag value to P-0001. Notice that it's still highlighted, but the status has changed from green to yellow to indicate that there is a mismatch between the Revit model and the original PID. Revit detects and displays a warning when there's an open connection or if there is a mismatch between the parts in the PID drawing and the Revit model. For now, let's change the value back to reconcile the mismatch. Next, let's start a modeling line. First, switch to a floor plan view. You can start with any part in the pipeline, so let's begin with this line segment. You'll notice that the size, system type, and the pipe type are automatically set. The offset or elevation is the only thing that needs to be defined. Let's set it to 15 feet. Add the pipe segment from the heat exchanger to the pump. As you create the 3D model for the PID, Revit tracks which lines are complete and which are still in progress. Next, switch to a 3D view to place the valves. As you do this, you'll discover that order is important. The PID lists the pump, then the check valve, and then the gate valve, and then the heat exchanger. Let's start by placing the check valve. Next, place the gate valve. Notice the warning indicating that there's a mismatch. Because they are out of order, the status is changed from green to gray. Let's undo the placement of the gate valve. This time, we'll place the gate valve where it is supposed to go, which is on the other side of the check valve. Notice the status changes to green because now everything is consistent between the Revit model and the PID. The only thing that is missing is the mapping for the heat exchanger. To demonstrate the change in status for this line, let's undo the last step. Notice the blue circle when the pipeline is incomplete. When you click Redo, it changes to green. The only thing remaining is to map the endpoint. Let's map E1007 to the heat exchanger to complete this pipeline. We are ready to move on to another line. Click the icon with the 3 dots to the right of the pipeline number to display a list of all the line numbers. Double-click on line 1061 to open it. You can continue with the same process to model this line. This time, let's work in a section view. Let's start with the vessel and add a pipe. Notice that as you start to model, the connector dialog prompts you to select which connector to use. In this case, 2 connectors were available in that location. Now draw the pipe, align it to the outlet, and click on the vessel to connect into it. Next, place the gate valve. Notice the indicator that displays if the valve is not fully connected. Let's switch back to a 3D view and try placing the gate valve again. Now it's fully connected. For the vessel, we're going to map the one from the PID to the existing one in the model. Notice that the yellow slashed bar is telling me that the mapping is set up differently from what is currently defined in the model. This means that the current family name doesn't match the one that's defined. To correct this, open the PID settings dialog and check the object mapping for the equipment. Click Object Mapping and click the Equipment tab. Let's add another type of vessel to match one that's in the model. Click the plus sign to add a row. For PID class name, select Vessel. For Revit family, select the correct Revit family. Alternatively, you could have just changed the existing value for the vessel. Doing it this way demonstrates how you can have multiple different families mapped to the same PID class. Notice the status bar changes back to green. You can continue to make modifications and even delete pipe elements. Notice the water droplet next to the line segment indicates that there is a disconnection in the pipeline. You can also change the routing of the pipe. When the pipeline is complete, the status changes back to green. You can continue to use Revit PID Modeler to model other lines from this PID. PID Modeler streamlines the process for modeling PIDs in Revit and ensures consistency between the PID and the Revit model.
All right, so I'll go back to my main screen here. So hopefully that gave you a good overview of PID Modeler for Revit. Now the video really didn't show it, but initially to get in there and get started, you would have to go into Revit PID Modeler. You would open up an existing collaboration project for plant, and that's what would populate the PID Modeler window off to the right there. And you could pick the drawings and lines that you want to model. So we do have some additional information if you're interested in doing more of a deeper dive into that. There's a really good Autodesk University class that was conducted on this, takes you through the whole process of setting up things on the PID side of things in plant, and then all the way into Revit on how you map objects and equipment and things like that. There's also a really good 57-page handout on that as well in that class at the top there. The Revit Help has information on PID Modeler with some videos and instructions on how you can set up your mappings. There's information on the Autodesk Revit blog, and then there's also a third-party blog down at the bottom that has a really good comprehensive overview of PID Modeler if you want to share that out with somebody just to get a kind of quick overview. So just going into the first topic here around exporting from Plant 3D into Revit, we're going to talk about the methods to do that. and there's two different ways. And the first one here we'll talk about is around linking the CAD geometry into Revit that you've exported out of plant. So basically, you're taking the existing plant models, you're using the export to AutoCAD command, and that's going to convert the geometry into something that Revit can bring in and import properly. Basically, it's going to convert it to just 3D solids. Because if you skip the step of exporting, Revit really doesn't have object enablers, so you're going to see wireframe, things like that. Using this method of exporting out of plant first, you're going to be able to see in a shaded mode all of the geometry that comes out of plant. Now, this first method here is a very simple way to do it, very quick. If you want to just drop it in and do some measurements or some quick coordination, this method works. The only drawback here is the issue with views and things like that, like the clipping planes, the bounding boxes, things like that for Revit views don't really work with these type of views. So just wanted to note that it's kind of like a temporary way of bringing it in, but it does work. You can go into manage links and reload those. And so yeah, I just wanted to show this first method. We do have a quick example of that. I'm going to bring this up here and show this other video real quick. So this is the first method for bringing in Plant 3D models into Revit. I'll go ahead and start this one.
For method number 1, we're inside Revit, and we're going to use the link CAD command under the Insert ribbon tab to import our AutoCAD drawing, which was exported to AutoCAD and is now straight AutoCAD solids. We use the positioning of auto origin to internal origin, and that will place it in our model. If we need to manage our links, we have the Manage Links tab, and under CAD Formats, you can see our link is there, and we can either reload it if it's been updated, or remove it from the model altogether.
All right, switch back here to my view. So yeah, just really quick, that's an easy way to link CAD instead of importing CAD into Revit. So just want to note that if you use this process going out of plant, if you want to include your XREFs, you want to use the XREF command and bind those references as a block into the Plant 2D drawing before you save and export that out. And then you just go through the same method here to bring it in. That way you're not missing any XREFs that might be in there. So that's method number 1. Going into the second method is a little bit different. You're basically importing CAD. So at this point, you're still exporting out of Plant 3D to get the Plant 3D objects converted over to something that Revit can import. And then you're just basically bringing that in as a generic part family into Revit and then placing that into the model. So similar method, but just a little bit different step there where you're going to import that as a CAD option. So let me go and we'll show a quick example of that as well. So I'll go ahead and start this one here. So this is method number 2. And we're going to Plant 3D to Revit. Here we go.
To use method 2, we take our AutoCAD Plant 3D drawing that's already been exported out to AutoCAD, so it's strictly solids. We're going to create a family out of that. So we're going to create a new family. So inside Revit, we do that. We're going to use the English. We use the metric generic model, which is right there. And then we'll go to Insert here, and under that ribbon tab, pick the Import CAD command. And we can go ahead and insert that in to our family. And when we zoom out to see it, we'll see that geometry is there. And we'll go ahead and save this Revit family. In this case, it's called a Family 3. We can rename that if you want to. And we'll call that out, save that as Plant 3D model. And that would be shared in a common location. Then we can go to our actual Revit model at that time. And in this case, we can go ahead and load that family up. And it's going to be available under generic models. You can see it right there. There's an instance of it right there. And we can create that in the model. And you can actually locate it or place it at 0, 0, wherever you'd like it to go.
All right, so it's just kind of an example there of importing CAD and bringing that in. So, you know, with that method, there is one drawback. Basically, you'd have to go in and reload or re-import that CAD geometry if you have to re-export out of Plant 3D. Now, there's another kind of a third method. Just wanted to show really quickly here in Revit. So if I go in here and bring this over to the screen, see if that'll show up. There we go. So within Revit, another option you can do, if you go up here to the Create tab, actually let me back out of this and cancel that. Get out of this model as editing. We'll just cancel that. So if you go to Component, you can model an in-place component. And what you're doing here is basically selecting the generic model again, but in this case, you're just going to link it into this this family that's being set up here. So I'll do this as Plant 3D example. And I will go ahead and go to the Insert tab, same method, but I'm going to link this in, and I'm going to go find the plant model that I had exported earlier. Oh, let me get this on the screen here. It's on my other screen, so take just a second. So basically, I'm selecting the plant model that was exported, and I'm just going to leave it as origin to origin. Now, it's going to take a second to import this in. It's going to read the geometry, but what this method does is it allows you to link it in. So let's say you've had some updates to the Plant 3D models, you've re-exported them. When you have it linked in this way, when you go out of the Revit model and close it and reopen, it's going to automatically reload. Alternatively, you can just go to your manage links and reload those if you know that they've been updated. So this is just kind of skipping the step of having to go through and import CAD again. This is linking it in sort of live so that you can just reload it every time. So kind of show example of that once this is done processing. It takes a second. Now it's going to give me a warning about the geometry, but it's really not an issue. It still imports everything properly. Now, if you're in a wireframe view, you may not see the geometry probably properly, but if you're in a shaded mode, you're going to see everything here. And this does adhere to views and levels and things like that. If I go into a level, you can see that I've got, it's kind of clipping the top of that skid unit there, and it's actually working fine with the clipping planes that I have from my different views. So that's, just wanted to point that out. And then once again, if I go back into Plant, re-export this, I would go up here to my manage links. Let me go ahead and finish that. And I would want to go in here to my CAD formats, and I would just click on this and reload that. So that would be a manual way to reload it, or like I said, if you go in and out of the model, it's going to actually reload that too. So that's kind of just a third way to do it, to kind of skip the step of having to re-import every time or import the CAD again. Going into the other method, going out of Revit into Plant 3D, there's a couple of ways to do this as well. The first one that we've tested and seen is around the coordination models. So basically, you're going to be using sort of like how you do it with XRF and AutoCAD. So what you would do is you would create your models, from Revit into Navisworks and get that set up as like an NWD, and then you can go into attach coordination model from the XRF command and just bring that in that method. So it's really a lightweight method because it's not really loading all of the geometry into the drawing itself. It's displaying it in the canvas, so it works really well with orbiting and zooming and things like that with complex models. The only drawback to this limitation would be that the geometry that's shown from the Navisworks coordination model really isn't detected by ortho drawings. So you couldn't really see what you're seeing with the coordination model on an ortho drawing. That the hidden line geometry just doesn't pick it up. But if you want to drop in like a Revit building or structural steel, anything like that, just for coordination within your model, this is a quick way to do it. It's not really going to impact the performance too much there.
I should mention also, Jason, at that point that the coordination model is snappable. So if you needed to snap to the center of the end of a piece of pipe, you can use the center where it doesn't use the nodes like we would normally see with Plant 3D objects, but there are some O snaps that work with that coordination model in in the AutoCAD environment. So
Yeah, that's true. And you really won't see the individual parts and pieces. It's loaded up like an XREF where it's all one model. But yeah, the snap points are something that you can use there for sure.
yeah,
Thank you
that's
for
a question that was asked actually in the
ah.
chat. That was you know, is there a way to get the intelligence in? And the coordination model does not bring the intelligence in. So unfortunately, right now, what we're showing you here is mainly geometry sharing. So, and I'll put myself back on mute, but thanks.
Thank you for the question there. Good point. Thanks, Joel. So the other method for bringing this in is to export out of Revit to a DWG file. Or if you have a piece of equipment, you could use a SAP file if you're going to convert that to equipment over in Plant. But basically, you're going out of Revit to a DWG, and that's going to set that up so that Plant can import that as like an XREF. Now there is an option in Revit you'll want to set. If you go down into the drawing/DXF export setup and you go to solids, make sure that's set to ACES solids. That way the type of geometry that's created is just a standard solid that Revit can read in, Plant's going to read in for the ortho drawings and can see that properly. If you use the polymesh, we've seen some issues with orthos where it doesn't really cut properly or things aren't displayed right, but the ACES solids is the best method we've seen so far. So I've got a quick, I think we got one example on that. Let me bring that up here really quick. So this is going from Revit to Plant 3D. I'll cue that up real quick.
Exporting a DWG file from Revit so that it can be used in AutoCAD Plant 3D is a fairly simple operation. The main thing is to make sure that you've reduced the level of detail in your Revit view and that you're in a 3D view, as shown here, of the model so that the geometry you expect to be exported will be exported in 3D. So in this case, if I had any small holes or layers that I could turn off, geometry that I could turn off that wasn't necessary for AutoCAD Plant 3D, it will save you a lot of time in orthographic generation as well as in overall model performance. So I'm going to go to File and I'm going to export. Under CAD formats, I have the option of DWG and also the ACES solids or SAT can be generated. These files tend to be larger, but you can take them into Inventor and do things like shrink wrap. Export those from there if you need to clean up equipment models for use in Plant 3D. But if we go out to a DWG file here, we recommend that you go to the export setup and modify that export setup to make sure that your solids that you're exporting are going to be ACES solids rather than meshes. And that will generate nice clean geometry that will be sent out to AutoCAD Plant 3D, and then you would XREF that drawing into your AutoCAD Plant 3D model that you create. And so you can call this whatever you want to. Just be consistent with that, because if you use it as an XREF, then you want to be able to have that XREF automatically update in Plant 3D by exporting out from Revit to the same file name and in the location that can actually be referenced by Plant 3D.
All right, so yeah, main points with that video is trying to optimize before you export out of Revit. Turn off anything that's not really necessary, like if it's a building and you don't need to see all the fixtures and furniture inside, just make sure you're exporting the building shell if that's all you need. Turn off some of the extra geometry because like I mentioned there, it's really going to slow down your orthographic view generation process once you get those over into Plant. And also we recommend that you use sort of a host drawing within the Plant 3D project so you can create a new DWG file within the project to sort of host the drawing that you're going to XREF in. That way you can overwrite the DWG file that you're saving out of Revit over and over and still keep that original model that's part of the project as part of the ortho view. It won't really upset anything by overwriting that file that exists in there, or that project drawing, I should say. So just kind of a best practice there with that. So let's see, we can move on here to Bin360 Design and talk about some of the coordination spaces that are available now that were, the Plant 3D 2021 integration has been moved to docs and design environments. So now we have some options here for setting up coordination spaces. So basically, within the Bin360 Docs platform, you have design and model coordination as two separate modules in there. So that allows you to take those models and share those out so that you've got design collaboration with other disciplines along with the document storage, and then model coordination allows you to get some clash detection in the cloud through that module itself. And so basically those will update automatically. For the clash detection, you'll get sort of a clash matrix you can go through. You can share views, markups, things like that within your web browser and invite people to view those, and those are all within Bin360 design and model coordination. So just kind of take a look at this real quick, how this works. So basically you'll set up project coordination and clash detection from the cloud within Bin360 under Project Admin. So when you go in here to Project Admin, you'll create a new coordination space, which is under your Services tab, and you'll basically name that and then select the folder. Now before, a few months ago, you could only select models from the plans folder. So now with the recent updates, you can now go into project files and you can have, for example, your own model coordination space there that you're using. So you'll set that up in the project admin, and then the drawings will go in there. The models will be in there, and that tells Bin360 that that's what it needs to read for the clash detection. So basically you'll select the folder you want, your coordination folder. And then what you're going to do is go in here and just basically set up that space, and then everyone will be able to use that within the services there. So that's pretty simple to set up. You can do multiple spaces if you'd like. That way you can have one for plant and one for other disciplines, things of that nature, and get all that set up from the Bin360 side of things. And then going into document approval. So the other thing you get with document management is approval workflows. So basically you can customize these per project. You can have single step reviews where you just send it to somebody and they have an approval, approve, decline, or you can have group reviews where you have multiple people that are set up to review these. So there's many different ways you can do this in the system there. So basically it's pretty flexible in all of this. It's similar to kind of what you get with Vault with approval workflows. This way it's all in the cloud and pretty easy to set up. So I've also got file stamping in here so that you can see the statuses within Docs on the approval process and how that's moving through. You've got some file copy options, and that's useful for when you get into the coordination spaces, because you can have drawings that are finally approved. They'll go into your coordination space folder, and then those are the final approved documents ready to be reviewed and going through for the clash detection. And then these are the options down here below, like where the approved documents get copied to. You set that up here within the options. Now for coordination space, this is kind of a typical example here. You may have a certain area or folder within Docs that you designate for your project files, and that's going to be where it's picking those up from. And then like mentioned before, you'll set that up as your coordination area and folder in there. So in this case, we're taking the Plant 3D models that get approved. They go into the approved folders location, and then that's where it's going to actually use the clash detection from there. And then the approval workflows that are set up. I've got a quick example of this just to kind of show how this works. So I'm going to go ahead and start that. This is the Bin360 coordination space. So I'll go ahead and start the video here.
So with our piping model checked out from the Bin360 project, we can make changes to it. And at that point, when we check it back into Bin360, we can set up an approval workflow that actually moves those models to the collaboration workspace. So we'll save this back up to Bin360 now. As the project administrator for this project that I've created here for Plant 3D, I can create a approval workflow. In this case, I'm going to create an Area 1 approval workflow that takes models from the design team's various locations, whether it's Revit, Civil 3D, Plant 3D, and moves those models to the Area 1 folder underneath the approved for models for folder federation location. I can define who's going to be able to initiate the process. This would be one of our model editors, and the approver can be one of our admins, or if we have a checker. And then we can specify here the location where those models will be placed after approval is complete, and they'll be copied there. In Bin360, under the Document Management module, we have our Plant 3D project location here. And it's located underneath the project files. And it has the different area folders that we talked about. And in that area folder, I can see the model that I just updated. And we can go ahead and submit that for review. If there was other models, we would select those as well. And this is going to be our Area 1 approved for coordination workflow. And that will be go ahead and initiated. We'll submit that. And the approvers will be notified that there is a review open. And they initiate the review. We can go ahead and send to other project members if we need to. The approver receives an email from Bin360 and can then initiate the review of that particular document set that needs to be approved for move to the coordination location. And here's the model. I can view it if I want to within the Bin360 viewer. Looking at it from here, make comments, necessary changes or whatever, and then we can go ahead and accept that. By starting the review here, it's setting this review to me, and we go ahead and approve it. Once we've looked at it, we can add comments if we want to, and that's reviewed. So now we can see that after the approval, our model, as well as other models that were linked to it and models that are came from other approvals, are all going to reside in this Area 1 folder. What's nice about this now is that these are all ready for review and model coordination, which we can switch to. And after the models have been put in there, a clash detection will be run in the cloud automatically. And you can see the clashes that are available for your models. If there are clashes out there, you can review them within model coordination space and see them, the different views. We could mark them up with comments if we needed to. And then finally with Navisworks, we can use the Bin360 coordination tab to open up a coordination space that's in Bin360. By selecting our project, selecting our drawing that we want to look at, and open it up, and we'll be able to review the clashes here, and if there are any issues, we'll see those as well.
All right, so just an overview there of the new coordination spaces that are functioning with Plant 3D now. See if there's any questions. We'll go ahead and pause here and kind of go through the Q&A chat, see if there's anything that's open. It looks like you've been answering most of the questions, Joel, so just see if anybody has anything they want to ask live. Looks like somebody's got their hand up here. We'll go ahead and unmute. Let's see. Let me do that. Oh. Let's see. Unmute request. Okay. See if anybody else. We've got.
Can you hear me?
It's a little bit low on the audio, but if you have a ability to turn it up or something, we can barely hear you. There we go.
Is it better now?
Yeah, it's better. Go ahead.
Yeah, perfect. So, hi, Justin. I just have a quick question regarding the Plant 3D model export to CAD, basically. So, for bringing it to Revit, is there any sort of application or plugin for Plant 3D that we can do the batch export? I've seen some plugins that you can do the whole project or a specific file, but I haven't seen a plugin that you can select which 3D models within Plant 3D you want to export to CAD.
Yeah, there actually is. I mean, the only thing I've really seen is a custom routine that was written by one of our enterprise specialists years ago, and it's just something that you load up into Plant 3D as a, I believe it's a DLL file. And it allows you to do a batch export from Project Manager. So basically, all of your 3D models, you could export those all at once. And I believe there's also a automated option where you could script that and run it on a schedule. So I'll find that and link it here. It's available through one of the Autodesk University classes. But yeah, that's the only thing I've seen so far, unless you were to create something through the Plant 3D API, which is basically what they did. That's the only thing I've seen so far. I don't know if there's any third-party tools out there, and there's really nothing built into Plant that has batch export currently. But we'll grab that and link over to it.
I appreciate that. Yeah, that's the only one that I've seen as well. But I was wondering if there is anything else available that you are aware of that you can select multiple files rather than just do the whole project. But yeah, I appreciate that.
Okay. Yeah. All right. Thanks for the question. Now let's see. I think there was another. Yeah, I'll go ahead and unmute you here, Todd. Give me just a second to the request here. There we go. Okay, you're live, Todd.
Can you hear me all right?
Yeah, sounds good.
All right. Well, thank you for holding this forum for one. It's good information. Always appreciate the feedback. We've actually been doing these type of parameters in our for quite some time. One of the things I was hopeful to see was some kind of like an intelligent connection between Revit and Plant 3D so that the intelligence and the componentry come across, and obviously that still hasn't been developed. Is that on the radar for Autodesk, or is that going to be something that's going to have to be a wait and see?
Yeah, I think that's kind of a wait and see. I haven't seen anything on the roadmap recently. We do get that question often. One workflow we were looking at is going through, well, it's basically iConstruct. So you'd basically take your Plant 3D models into Navisworks, and then iConstruct could go out to a smart IFC file, and that will go into Revit. But I still, we did some testing on that, and I still don't think you can select down to like the individual component level. I think that's the kicker there is in Revit, you can't necessarily select and get data for like structural steel, things like that.
We've actually played with that as well, and what happens is that it remains the exterior shell. I think I can't remember. It remains a mesh basically.
Oh, okay.
And
yeah.
when you bring it into Revit, what happens is that mesh dominates. It doesn't have the capacity to go from the simple single or hide the faces, and so we played with all of these different things, because what's happening is that we have a deliverable to a customer that's a Revit model, and so we're trying to figure out how to get from Plant into a Revit that's in a format that they can accept. And we're still fighting our way through trying to figure that out. And if there was a, similar to like with the fabrication MEP, they've got a cleaner pathway through. We've even looked at trying to go from one format to the other, and it still is not clean. So just curious if that's something that's on the radar, but
yeah, you may want to look on the Revit Idea Station and Idea site, see if there's anything out there, and post their vote on it. I could propose a question to the product team and just see if there's anything in the works, or if they're aware of that. I thought maybe down the road they would have something where, now that we've got Plant 3D and Bin360 in the cloud, it has the properties there. If it would somehow, you could import that down from the cloud into Revit and then maybe merge that in, or have that part of the model, that would probably help. So maybe something like that's in the works. I'm just not aware of it. We'll check into it and give you some feedback on that.
Okay, fair enough. Well, thanks again for your efforts here.
Yeah, absolutely. Thanks for the question. Let's see if we've got anything.
You got Todd. Todd was actually had his hand up there. Is that? That's who was just speaking. Okay.
Right. Yep.
I think all the questions have been answered. I think. Let me just take a quick look. Oh, does Revit handle custom Plant 3D catalog items? When you do the export to AutoCAD from Plant 3D, you're going to get all of the custom plant objects are going to be converted to solids. And if you've got custom Python scripts that you've created using the Python primitives, the Plant 3D supports, it still should come out as a solid. If you've got block-based geometry in your catalogs, then those will just be AutoCAD blocks that will be transferred over. So there's no conversion from a custom plant object necessary. So that's for Michela's question in the Q&A. So.
Okay. All right. Yep.
Yeah, I think that a lot of good questions here. Just to go back to Todd's question, you know, the common data environment has kind of been the dream that we've all been chasing for years, and we've always been kind of looking for that in a particular file format. You know, is it DXF? Is it IFC? Is it you know, FBX or whatever? And each one has its own strengths. You know, you might go with FBX if you're going to go to 3D Studio Max and do some, you know, animation. You might use IFC if you're trying to go into Revit to get as much BIM data as possible. But you know, a true common data environment is probably going to be one which is file agnostic, you know, in the larger sense, where you can import and export to that common data platform a lot of different file formats. And that's probably where you're going to see the future going. If I can, you know, prognosticate here, but then the NDA comes into play, is that this is just Joel's opinion, not Autodesk's opinion. So, but that's probably a good, you know, way to look at technology as far as where it's going. I don't think that we're going to see an ISO 15926 file format come out next year that's going to solve all vendor problems and all application file format problems. So, but that's just my perspective. So, but yeah, I think that yes, the recording will be available, Ramon. It's going to be available on our Autodesk University site, basically, or I'm not Autodesk University, the community meetup site, same place that you registered. There is actually a place for all the past recordings, as well as the PowerPoint decks. And the PowerPoint deck that we have here is going to be available up there as well. So.
So I got one question here from Lucas. I'll go ahead and unmute you, and I think I'll let you ask the question here.
Forgive my English, but I have a kit to work with, a mechanical kit to work with Inventor, to tanks and pumps, and I sent to Plant3D, but in Plant3D don't have an intelligence, only the nodes, okay? And when I export to Revit, goes all information I send goes to Revit. And I work with a plant of mining, and I think Revit is the future program of all plants, or Plant3D goes to a better to BIM, because Plant3D is not BIM to mechanical, for example.
Do you want to cover that one, Joel, or start with that?
Yeah, I was just going to say, it sounds like, Lucas, that you'd like more information to come across from Inventor into Plant3D, like you're seeing in Revit. And it's true, Revit is really a BIM platform. And AutoCAD, you know, we started calling them attributes, and then we call them properties, and we try to get as much in there as possible. The ADESC file format, ADSK, which is probably your best route from Inventor to Plant3D, as you said, it only comes across with the nozzle information. It doesn't have anything about the equipment itself. And so you have to kind of apply that, you know, to the tags in the Plant3D database. And we've seen people develop tools to do that, to read it into the Plant3D database properties there, because it's really, that's kind of where all the quote unquote BIM information is for Plant3D. So, but yeah, that's kind of just the way things work. They're architected differently right now, and since I totally understand where you're coming from, though, for sure.
Yes, because I have a problem. I make a list of equipments in the Plant3D. Okay, I don't have problem to make this, but all information I send to Plant3D, personal information like potence and power, horsepower. I don't remember the measure. All these don't go to Navisworks. I have to send the other forms to go to Navisworks, or to send the archive directly of Inventor. And I see the Revit like the program to absorb all information, and this is my problem. It's a question, but I wanna think about this. And we need the program to absorb the information, to federate and really federate it. This is my problem. This is my answer. And I hear in three conversations of this and questions with these questions.
Yeah, well, you're not alone. Basically, Revit is very BIM enabled. It's a BIM platform. It's very much a database, really, more than a graphics file format when you're looking at Revit files. It has the ability to handle very large models, and whereas AutoCAD struggles sometimes with large models, and AutoCAD is what Plant3D is built on. And then you end up the fact is that Revit doesn't generate isometrics, and it's not spec driven. So you don't have that sort of tool set to work with like you do in Plant3D. So they each have their strengths and their weaknesses. So it's what we're finding is that people have a combination of needs out there. If you have a lot of basic environmental water systems or stuff that's at atmospheric pressures, and you can do those with sort of an MEP solution, which Revit provides there. Conveyors, air handling, that sort of stuff. When it comes to mining, that aspect of it. But when it comes to higher pressure systems, you're probably going to need a spec-driven tool to work with that design part of the design, and that's where Plant3D comes in. So the need for interoperability is where Jason and I are here. We've been presenting at AU or writing about these things in blogs over the past few years to try to give people the best solutions we can come up with while our developers are working on the grand scheme behind the curtain. So this is about the best we can kind of share with you today.
Okay, thank you.
Yeah, you bet. Jason, did I speak for you incorrectly there?
No, I was going to say maybe I take that down, do a little bit of research and check with the manufacturing group, because there might be some ways to go out of Inventor that will bring over some of that BIM data. I think it's changed a little bit over the years. I remember you could enter in a lot of the nozzle information inside of Inventor, and it would go through ADSK, and you could kind of get that into the Plant3D side of things when you imported it in, but I don't know if I've tested that lately in the newer versions, if it still works.
Yeah. No, there's also a question from Brandon in the chat, in the Q&A about Revit and Advanced Steel. Because there's an Advanced Steel add-in to fully support architecture items. Right now, the Revit to Advanced Steel is limited, but it does allow you to sync up your Revit model, structural model, with your Advanced Steel model, and then the Advanced Steel model is what you bring into Plant3D. And for if that's what your needs are for Revit, that does solve it, but it is limited right now. So we can't answer right now what the roadmap is for that Advanced Steel plugin, but that would be something that if you do post that in the Idea Station or in the forums for Revit on the Autodesk forums, the Revit team is monitoring that, and we have people that would be able to answer it there. So,
yeah, that's probably the best place for that question. I haven't seen anything around the steel add-in with architecture items, things like that. Let's see, we've got a few more minutes here. I don't see any more live questions. I think we've covered everything in the chat so far. We always add some links here at the end. I'll go ahead and scroll through these. We've got YouTube playlists. We've got Plant3D with the experts, and we try to post these at least once a month into different series. So there's a link here that'll take you to that playlist. We also have, the tutorials we mentioned about for Revit, some of the online classes that are available, resources, things of that nature. And then just Bin360 in general. If you're new to Bin360, there's a site, learnbin360.autodesk.com, that'll take you through the different modules. Those are all free online learning, sort of self-paced there. Help you get started with those. And then, of course, the Customer Success Learning Hub, where you can find the articles, previous webcasts, things like that. So we're going to upload these too. And then the communities coming up in the future, you can go to the site here and basically sign up for the different community meetups for your geo. And also wanted to mention one last thing on the health dashboards. If you're using cloud collaboration for Plant or even Revit work sharing, you can go in here and subscribe. Now for Plant3D, you'd want to subscribe to the Plant3D collaboration services, and that way it'll email you if there's going to be upcoming maintenance on the services, or if the services go down, you'll get notified so you'll know what's going on in a timely fashion. So just want to mention that as something you may want to sign up for. And I think
Yeah,
that's
and
all.
then also
Yeah, go ahead.
the docs versus team there.
Yeah, that's true.
Also, depending,
Yeah.
because maybe sometimes that the Plant 3D service might historically go down, for a weekend service maybe once or twice a year, but Bin360 docs for 2021 Plant may have a separate downtime. And so you'd want to subscribe to both of those if you're using Plant 3D 2021. And if you're using Bin360 Team with earlier versions of Plant there, you'd want to subscribe to that one so that you're aware of any planned outages. Most of the outages that I've seen, once again, you can't hold me to this, but they're usually fairly quick and they're planned weeks in advance. And they're on weekends so that they're not going to be a high impact. So working with customers that use Bin360 platform quite extensively, I've had very few complaints about the dashboard service and the planned outages. So it is something worthwhile and stable.
All right. Well, thank you all for joining today. We'll go ahead and close out the session and talk to you next month.
Thank you, everybody.